Number 7 is a 3x3 system that we need to solve. So again, I'm just going to go through this really quickly. It's just to find a variable that looks like it's easy to cancel out. And I think the y's look the easiest to me. They're all just plus y's. So I'm going to cancel out my y's. So I have to cancel it out twice. Remember, we need two equations, equation 1 and 2, that both of them don't have a y. So let's just, I don't know, let's just choose the first two first. And I'll multiply the bottom one by -1 and the top one by 1. Keep it the same. Now if I rewrite this, I just get 4x, y, 3z is equal to 7. The bottom, I'm going to distribute that -1 to everything, so I get -3x, -y, -z, and -9. So make sure you're careful with your signs. So here I get x, those are gone like I wanted. Here I get 2z, positive, and that's -2. So that's equation 1. Then I'll choose two other ones. So which ones do I want? First, let's see, I guess I will choose whatever, it doesn't matter. I'll choose the bottom two. And I'm going to multiply this bottom one by -1. So let's see, if I redo this one, top one I get 3x, y, z, and 9. The bottom, I'll distribute that -1, I get -x, -y. I hope I'm getting this sign right. I think that's a plus right here, so this will become -2z is equal to 3. And if I add straight down, I get 2x, gone, which is what we want. -z is equal to 12. Did I get that? Oh, no, this one's negative. Good thing I checked that. So this should be 6. Right, and so there's equation 2. And now both equations we see are two equations now that don't have a y. Now we stack those up and we eliminate another variable. So I have x plus 2z is equal to -2. 2x minus z is equal to 6. And let's see which variable looks nice and easy. Both of them do. So I'll just multiply the bottom one by 2 to cancel out the z. So I'll have a -2 and a +2. If I do that, I get x plus 2z is equal to -2. The bottom, I get 4x minus 2z is equal to 12. And my answer gets 5x, those are gone, is equal to 10. Now that I only have one variable left, it's easy to solve. X is equal to 2. And I look at this, and no, it's not x equals 2. Or I don't see an x equals 2, but it's obviously not 3. So now we just have to do some back substitution into our equation 1 and 2, and then into one of the original equations to find y and find z. So next, we'll plug it into, I guess, let's plug it into the second equation to find z. So if I do that, I get 2 times x, which we know is 2, minus z is equal to 6. And so this is 4 minus z is equal to 6. If I subtract 4, I get -z is equal to 2. And so z is -2. And there's my answer. So just in case you don't see that answer, we could always find out why, and we'll see it's not going to be 6. But let's plug this into an original equation. I'll just choose the last equation. So x is going to be 2 plus y plus 2 times z, which is -2. And if I do this, and let's combine those like terms, y minus 2 is equal to 3. And if I add 2, we get 5. And I see it's supposed to be, this says 6, it's supposed to be 5, so it's not none of those. Now, unless everything cancels out, it's not going to be this, unless everything cancels out. If you get an answer and it's wrong, it's probably because you just messed up. It's not because it's infinitely many solutions or no solutions. Unless, again, everything cancels out and you have no more variables left, then it's infinitely many solutions or no solutions.